All right, let's talk about exams. Have you ever wondered what's really going on in an examiner's head when they're grading your physics paper? Well, today, we're going to pull back the curtain. We're taking a real AQA GCSE Physics question, and we're going to break it down step by step using the official mark scheme. This is all about seeing exactly what they want so you can get every single mark. Let's get into it and crack this code.
So, here's our roadmap. We'll kick things off by just decoding the question. Then we'll figure out how to write the perfect explanation to grab those long answer marks. After that, we're getting into the math, picking the right formula, showing all your work, and pulling data from a graph. Finally, we'll put it all together to absolutely nail the last part of the question.
Okay, first things first. Before we even think about writing an answer, we need to get our heads around the basic setup, the context the examiners are giving us.
So, this is the opening line for the entire question. It seems pretty simple, right? But it's so important because it sets the scene for everything that's about to come. The whole thing is about the physics of stopping a car, thinking distance and braking distance. Got it? Good. Let's keep that in mind.
Right, here's our first real challenge. It's a 4-mark question, and it's a written one. You know, this is the kind of question where so many points are either won or lost. Let's make sure we win all 4.
The question asks us to explain the effect of 2 other factors on the braking distance of a car. Now, that command word explain is a huge clue. It means we have to give a reason, not just a list. And it's worth a good 4 marks. Oh, and notice it says do not refer to speed, a classic exam trick to make sure you're reading carefully.
And here it is, the secret recipe, straight from the official mark scheme. To get full marks, you need a perfect pair, a valid factor and the scientific reason behind it. So for example, you could say poor road conditions or worn out tires. That's your first mark. For the second mark, you have to explain why. And the key phrase is because of decreased friction. Or you could talk about the car's mass. An increased mass means more kinetic energy, so more work is needed to stop it. You see the pattern? It's always factor plus explanation. Just listing stuff won't cut it. You have to explain the physics.
Okay, on to the next bit. This part tests your memory of the key equations. It's a really quick 1-mark win, as long as you know your formulas.
So the question is simple. Which equation connects acceleration, mass, and resultant force? They give you 4 options. This is a straight-up test of one of the most fundamental equations in all of physics.
And the answer, of course, is resultant force equals mass times acceleration. You know it as F equals ma. This is Newton's second law of motion, and it is an absolute must-know. You've got to have this one locked away in your brain.
Now, let's get calculating. For a 3-mark question like this one, here's the deal. The examiner doesn't just want the final number, they need to see how you got it. Showing your working isn't optional, it's essential.
So the problem gives us our numbers, a force of 7,200 newtons and a mass of 1,600 kilograms. It wants us to calculate the deceleration. And do you see the connection to the last question? We're definitely going to need that F equals ma equation.
Okay, look at this. This is how you get all 3 of those marks. You get 1 mark just for putting the numbers into the equation correctly. That's the substitution. You get a second mark for rearranging the equation to solve for A, and that final beautiful third mark is for getting the right answer 4.5 meters per second squared. And here's the best part. Even if you mess up the final calculation, you can still bag those first 2 marks just for showing your method.
Next skill up, getting information from a graph. This is all about being careful, being precise, and making sure you're reading from exactly the right spot.
So here's our graph. It shows thinking distance and braking distance at different speeds. Our mission is to find the total stopping distance when the car is doing 80 kilometers per hour. So, step 1, find 80 on the horizontal axis at the bottom.
But before we start pulling numbers off the chart, let's just quickly remember the basic formula here. Your total stopping distance is just your thinking distance plus your braking distance. Easy.
And this is how it works. You go up from 80 kilometers per hour. The line for thinking distance is at 15 meters. The line for braking distance is up at 38 meters. You just add them together and you get your answer, 53 meters. That's a mark for reading the graph correctly and a second mark for getting the right sum.
Right, we are on the home stretch now, the very last part of question 1. And this one's a big deal. It's worth 5 marks. It pulls together a bunch of different skills, remembering another formula, doing a calculation, using standard form, and getting the units right. Let's break it down.
First up, it's another formula check. Which equation connects area, force, and pressure? Just like before, they give you 4 options.
And the one you're looking for is pressure equals force divided by area. P equals F over A. Another one of those formulas that's just got to be in your mental toolkit.
And now for the big calculation. Force is 60 newtons, pressure is 120,000 pascals. Our job is to calculate the surface area. But hang on, check out the specific instructions. Give the answer in standard form and state the unit. Each of those is a potential mark, so don't miss them.
And here's how you grab all 5 of those marks. 1, for substitution, just plugging in the numbers. 2, for rearranging the formula to get A on its own. 3, for the correct answer from your calculator, which is 0.0005. 4, this is a crucial one, for converting that to standard form, 5.0 times 10 to the minus 4. And that 5th, easy to forget but vital mark is for adding the correct unit, meters squared. Every single step matters.
Speaking of getting every mark, I want to leave you with a golden rule, and this comes directly from the AQA examiners themselves. It's the principle of right plus wrong equals wrong. Now, what does that mean? It means if a question asks for 2 answers, and you give 2 correct ones but add a 3rd incorrect one, that mistake can cancel out one of your right answers. It's a powerful reminder to be confident, be concise, and don't just write down everything you can think of.
So there we have it. We've completely dissected an entire question. We didn't just find the answers, we figured out the method for scoring marks. We've seen how to structure an explanation, why showing your work is key, and how to pay attention to every little detail. So the final question is for you. Now that you've had a peek inside the mark scheme, how are you going to use this way of thinking to tackle every other question on your exam?